Greetings, fellow grade 11s. Look, it's Mr. Hlajoy, and I'm back again with probability, right? Now, we are still examining our paper, which is our we are still examining our 2018 paper, right? From, this is November 2018, right? So now let's see in terms of what is it that we can do here. Now, they say, on a flight, passengers could choose between vegetarian snack and chicken snack. The snacks selected by passengers were recorded. The results are shown in the table below. Now, they say, was the choice of snack independent of gender? Motivate your answer with relevant calculation. Now, what is it that we are going to do now, firstly here? Now, in order for us to determine whether this is relevant to that, what is it that we are going to do? We are going to say now, there are many ways that we can do, but the most easier or basic way that we can do is, firstly, we can look at what is the probability. Firstly, let's say the probability of taking the vegetarian snack, right? Which means the probability of taking a vegetarian snack multiplied with the probability of male, right? And see in terms of what is it that you are going to get. Now, look, now what is the probability of, firstly, the vegetarian snack? The probability of getting a vegetarian snack, irregardless of this gender, it is going to be what? It is going to be 32, right? So we are going to have 32 here. We are going to write this 32 out of what? 150, which is the sample space. Now we multiply this by what? Let's say now we want the probability of what? Of male, irregardless of whether this is taking a vegetarian or the chicken, which is going to what? Which is going to be 67 divided by 150. How to get? And the answer that you are going to get here is, we are going to get, if you plug this in our calculator, this is going to be same as, yes, this is 0.09 or 95 rather, right? So this is going to be 0.095 rather, right? Now, so that is going to be the probability if you are having vegetarian and what and you are a male altogether. But now, if you can say, now we are looking for now the probability of what? The probability of vegetarian and what? And what also the probability of vegetarian and male, right? So we want to check their intersection, whether are they going to be equal. Now, what is going to be this? This is going to be what? This is going to be same as a male and vegetarian, and same as what? Same as 12, right? So this is going to be 12 over 150, right? And what is going to be the answer that you are getting here? 12 over 150, same as 0.08 altogether. And now, according to independence, isn't it that from independent formula, the probability of isn't it that the ordinary formula, it says the probability of A multiplied by the probability of B must be equal to the probability of what? Of A and B. Isn't it so? So now in this case, we are having the probability of vegetarian multiplied by the probability of male, which must be equal to the probability of you know what, the probability of vegetarian and what? And your male. But in this context, what is it that you are getting on this side? Here you are having this is 0.095 this side, which is not equal to the 0. What? To the 0.08 altogether. These two values are not equal. So which means you can now provide the conclusion that, now look, the probability of V multiplied by the probability of M is not equal to the probability of what? Of V and M altogether. So therefore you can conclude that these are what these events are not independent. The events are not independent, right? The events are not independent altogether, because if they were independent, now they're supposed to be like that. So basically that's what we do when you prove independence. Then you just take your 5 marks, you go, you move, right? Let's look at now our 9.2. 9.2, what is it that you are given? This one, look, they are saying now, they say for any, now they say for any of these what? For any of those two events, A and B, it is given that the probability of A and B, it is what? It is 0.12, and the probability of A or B, it's 0.8, while the probability of B is 4 times the probability of A. Look, Now, the easier way, I know some of you, when you panic, you tend to panic when you see this. And these are just simplest things that you can just simply carve, right? Now, what is it that you are going to do? Let's start here. Now, the first question is, are these independent? What are these events mutually exclusive? Now, for mutually exclusive, isn't it that for mutually exclusive, the probability of A and B must be equals to 0 for mutually exclusive. But if you can check here, you have the value for probability of A and B. So therefore, we are going to say no. Your answer is no. Why is it no? Because the probability of A and B is what is not equals to 0. It is actually what the probability of A and B is equals to what is equals to 0.12, is equals to 0.12. So therefore, these are what are inclusive. So these are inclusive rather than exclusive altogether. So that is going to be now the first question. Now, thereafter, what is it that you are going to do? The next question is, it wants us to calculate what is the probability of what? The probability of B. Now, obviously, because we are improving mutually inclusivity, right? We are definitely going to use it. But now, in order for us to use that, let's start here. Now, if you can say now, the probability of what? The probability of B is what? It's 4 times A, which means now wherever there is probability of B, you can substitute the 4A, which means now if you were representing this, if let's say the probability of A was equals to X, the probability of B was going to be what? It was going to be what? It was going to be it's going to be 4 multiplied by the X. Isn't it so? Hopefully you get it in this context. Now let's use it. Now what is it that we are then going to do? Now from here, we are going to say now, look, these two events are what are mutually inclusive, which means now from mutually inclusive, the probability of A or B is same as the probability of A plus the probability of B. Subtract the probability of what? Of A and your B, right? And now when you are doing like this, what is it that you are going to do? You come in here, you just substitute. Do you have the probability of A or B? Yes, it is 0.83. You come in, you plug. Do you have the probability of A? Absolutely. The probability of A, remember, you are given by what? You are given it by X. So the probability of A is your X. Plus, what is the probability of your B? The probability of your B is your 4X. Yeah, he's a man, right? So which means now after that, the probability of A and B, it is going to be what? The probability of A and B, it is going to be 0.12, right? Then you come in here, you just now you take this one, you take this number this side, right? Which means now you are going to add. So this is going to be same as 5x. Then when you take this 0.8 from this side, it is negative, so it's going to be positive. And when you say 0.83 plus 0.12, the answer that you are getting is 0.95, right? Isn't it so? And now when you're saying now 0.95, then you say now you divide by 5 this side, you definitely divide by 5 this other side, then your value of your X is going to be 0.19. And when you are having that as 0.19, look at me writing this not nicely. We are saying this is 0.19. And when you're having this as 0.19, then your problems are solved, because now look, the X represented the A, which means the probability of what? Of A is equals to 0.19. But that's not what you are looking for. You are looking for the probability of B, which means the probability of B, because it's 4x, the probability of B is going to be same as what? It's going to be 4 multiplied by the 0.19, right? And you absolutely have your answer, which is going to be what? Which is going to be 0.76, 0.76, right? Nice one. Then you go to now to your 9.2.3. Now you are looking to find this particular answer. What is it that they are looking for there? They say the probability of not A. Look, let's go here. Let's start here. You know that the probability of A and the probability of not A, these two must give you what? The probability of not A must give you 1, because these are what? These are complementary events, right? And whenever now you are looking for the probability of not A, the probability of not A, it's going to be 1, subtract what is the probability of A, which is 0.19. And you are having your answer, which is what? Which is 0.81. Okay. So basically, this is how you are going to tackle these particular questions. Thank you very much.